Okay, so I recently got a comment from a farmer near us, and his wording goes something like this. I think a system like this would work well if the grain doesn't need a bunch of moisture removed. The trouble with our air, I think he means up here in Minnesota, is it seems too high of humidity and the days are super short, especially into September. So that's why I hesitate running fans if the moisture of grain is plenty wet. Usually it ends up with a high electricity bill and the grain is still wet. So he is exactly correct. That is what happens. And I will show you why, if you don't have something like this, why that happens. So, first off, I want to look at this Clemson EMC calculator. So this is the equation, the calculator that our system uses to know when to turn the fans on and when not to turn them on. So how this works is, let's say it's 70 degrees outside and you have a relative humidity of 70%, right? And you have beans, and then we use the Chung method. That's the mathematical equation. So at that temperature and that humidity, this is what the moisture content will be in the air. So if you target 13.5 or 14% moisture beans, let's say, then the air with these two equals that. So you would not want to run unless you have like some super dry 9% beans and then you're adding moisture. So that's the air that pushes in. If these were corn, if this product was corn in this bin and you left the humidity and the temperature the same, the equation makes it 14. So each commodity sees it differently. So when someone says, I watch, excuse me, I watch my humidity outside and I just turn them on when the humidity is low, or if it's high to add moisture, well, you, you're still to know that range exactly where you should turn it on and off is about impossible. So if I go into our bin here, um, let's go to the graphs quick. I'll try to make this fast. So we filled it. I'm not 100% sure. So August 29th or so, and you can see our moisture there. The bottom sensor 1 is the bottom of the bin, sensor 12 is the top, and it's 16, so even some 17 in there. So this was really wet. I actually don't recommend putting it in that wet. Usually we like to be at 16 or less, just because we don't have heat on this bin. So, and then as it ran, and then like today's, if we put it right over here till today, it's just being stored now, not really running the fans anymore. But your bottom is 12.9, and you can see the 13.2, 13.5, 13.2, 3, all the way up, and then the top is 16.1 and 15.3. So why we have that is we did not take the peak off. So if you don't take the peak off, there's more grain pressure there, so the air takes the path of least resistance, right? So it's going to push out toward the top and you're never going to get the peak. And this is a prime example of why you want to core the bin and suck that top down a little bit to equalize the pressure, because the air will flow up and out depending on your peak. So that's what we got there. There's only probably one sensor up there at the top that's in grain, so it's showing that. So hopefully we can blend that off coming down, as it unloads through the bin. But our first load will probably be a little wet because of our mistake. So here's our running hours. So what I'm going to do is I'm going to show how the system knows to run, why it does it, and when it does it. So let me pick a day here. So this day, okay, this graph works like this. Here's midnight, noon. 13 is that top sensor by itself because it's a longer cable, so there's probably one or two extra sensors on that one cable. And then these are all the average of, if there's 4 cables, there's 4 sensor 11s, and it averages them each hour. We can look at each one individually if we want, but for this, we're just gonna look at the averages. So like sensor 1 would be the bottom of the bin, and that's right there is each hour. It gives us a report. So on this day, this was October 15th, we know it ran in our pressure column here. When we got 5.5, that's inches of water. So that's just showing us we have pressure in the plenum. That means the fan is running. So as you can see here in the weather station, at midnight, it's 18.4% moisture in the air, and it's just getting wetter and wetter and wetter. So if someone turned their fan on at 6 a.m., you're pushing 22 almost percent moisture into your grain. And then at about 11, it gets 16 outside. And I should clarify too, the plenum here shows us the moisture content under the floor that's going into the grain. So after the fan and into the grain is different because the fan creates pressure, which dries the air some. So if you're not measuring under the floor, you're not really knowing what's going in to the grain. So, and then, so the system saw this and thinks, well, under the floor, I'm 13.7. That's dry enough. That's what we want. So it kicks the fans on and it runs all these hours. You can see what's getting pushed through the grain here, the 12s and 11.8, 12, 12.7. And then it shut off right here at 9 p.m. at 15.1 because it knows what's all in the bin and it's calculating what moisture it needs to dry it down. So if I go to the next day, so that shut off at 9 and then it's off all the way until 11 again. So then it goes you can see the moisture contents there, till midnight. And then one more day and we'll just kind of see how it progresses because each day is different. Oh, it ran all night. So sometimes it runs all night. Depends on the weather, right? Depends on that calculation. So then 7 a.m. it stopped instead of turning on for a few hours. Got a little too wet, and then it dried off again once the sun burned off the humidity, I'm guessing. And then it ran again until 9 p.m. So all these hours is useful air, not wasted. So I hope that kind of clarifies the why if you just leave your fans running day and night, it goes up and then it goes down, and it goes up, and then it goes down. So you're really kind of just staying the same and you're just burning electricity for no reason. So that's where we save the electrical costs and and get good loads going to the elevator. So there's another that also adds to our profit. So um yeah, if there's any other questions like this or concerns, I can go over anything like this with you on a Zoom. We can do it in person. Either way, it doesn't matter to me. So my number is 218-686-9015. Thank you.